Okay, guys, so today, kind of a little bump in plans. We're not going to test today, so we're going to teach you one of the days. We're going to kind of swap days with what we were going to do on Thursday. Geometry teachers, we asked them kind of what would help them the most. They asked us to teach you radical operations. So we're going to start with adding and subtracting radicals first, just because usually it's easier than multiplying and dividing. All right, so rules. Y'all, we know y'all can follow the rules. Number one, here's the goal, and here's what we need you to do every single time. You're going to start with simplifying all of the radicals. Okay, that's not a, I'm going to think about it. That's a, I'm going to do it every single time first. So you're going to go through, simplify all the radicals first, and then see what things look alike. And remember, we taught you to simplify radicals with a Christmas tree. Kind of good that we're doing this right before Christmas again. You can do it like that. And some of you have gotten to where you can actually do it with simplifying by radicals. So if you can do that, that's another way you could also do this. All right, so we're going to start with simplifying radicals, like our Christmas trees. Then we're looking for radicals to have the same index. You remember index is the little number outside of the radical kind of sitting on the ledge. Okay, so if it's like a square root, a little 2 would be the index. Okay, because he's kind of sitting on the ledge of the radical. Maybe a cubed root has a 3 sitting on an index, sitting on the little ledge. Okay, so remember that the parts of a radical, we've talked about this. This is the index right here. This is the radical, and this is the radicand. Okay? So the rules say identify radicals with the same index and same radicand, basically terms that look alike, like terms. Only these can be combined. Okay, so number 3 says for common radicals, add and subtract the coefficients. Remember the definition of a coefficient is the number being multiplied by a variable or by a term in some way or an operation, and then keep the common radical. Okay, so watch Ms. Delkina. First things first. Number 1, we're going to simplify any radical that can be simplified. So she knows that radical 20 can break between radical 4 and radical 5, or we're doing it like a Christmas tree. So remember, we break down all of these to prime factorization. And remember, we taught you about going out on dates. It takes 2 of the same number to go out on one date. So notice that on this radical, she already has a -2 out on a date. And then she's going to take those 2's, put them together, take them out on a date. And then 5 would stay at home. Okay, so she broke that radical down. She simplified it. And technically, that would become -4 radical 5. Okay, notice what she did here. She did -4 right here, radical 5, and then brought down her other term, which is -2 radical 5. So it turns into -4 radical 5 minus 2 radical 5. So remember, when things have a like term, that means they have a like radicand and index, you can put them together. So because -4 has a radical 5 and -2 has a radical 5, you can combine these like terms. The answer would be -6 radical 5.
It's almost like saying if you had -4x and you subtracted 2x, you would have -6x. Very similar in concept.
Yeah, very similar. That's kind of how we teach it, is just basically putting together like terms. And think about the radical as being a variable. It kind of makes it simpler to understand. Okay, pretty easy concept. That's why we chose to do this for a few days before Christmas. Okay, number 4, she's going to break her radicals, try to at least. So radical 15, she tried to simplify, you see that? And then radical 60, she's making a tree. And she's breaking it down into 6 and 10, and then remember she went to prime factorization, all her primes she circled. So remember about radical 15, technically it doesn't have a simplification because no one can go out on a date. There's no 2 numbers that can get together and go out on a date. But radical 60 obviously can have a date of 2's. And then 3 and 5 would stay home. Okay, y'all know this concept, so it's just kind of taking it a little bit further. So radical 15 is in simplest form. And then remember, -6 was already out on a date. She multiplied it by the 2 that could go out on a date. So these 2 make -12. And then 3 and 5 stayed home, so they make 15. And notice how she's got a like radicand right here. The radicand is the same. The index is the same because both of them are square roots. Here's what you can't forget, that there's an invisible guy right there. That one that she just drew, So technically she has 1 minus 12, which is negative 11, and then we keep our common radicand. Okay, see how easy that is? Not something that's going to be too hard. Okay, I'm going to do one on the back, couple on the back, just to kind of like make the process so you understand it. We chose the number 12 because it's got a lot of radical simplifications in it. So she's going to simplify radical 8 into what, 4 and 2, and then 2 and 2. And she's going to try to simplify 96, which would be 12 and 8. I could do 12 and 8. Circling all those primes. Remember, we're dealing with the primes. And then she's going to try to do radical 24. We ain't got enough room, but we're going to go out to the side. And remember, here's what you got to remember. Remember, we could do 24 like 4 or 5 different ways, but all of them would get us the same answer. Okay, so just because Miss Delk chose 12 and 2, you could choose 8 and 3 or 6 and 4. Okay, so she simplified all those radicals. All right, now number 12. So here we go. 2's on a date. And then another 2 is going to come out. She's going to cross those out, take that 2 on a date, and then a 2 would stay home. Okay, let's go 96. So 4 is already out on a date, so she's going to go ahead and put him. And then, let's see, those 2's get together, go out on a date. Those 2's get together, go out on a date. And that leaves 3 and 2 at home. All right, 24. Technically, there's a 1 out on a date already, but you don't see him. And then just the 2's would get together, go out on a date, and then 2 and 3 would stay home. Okay, see all that work? And then we're just going to simplify. So the first one, we would have 4 radical 2, and then plus, let's see, that'd be 8, 16 radical 6, and then we would have negative 2 radical 6. All right, we're going to combine like terms. Remember, they have to have the same radicand and index. The index on all of these is a 2, so we don't have to worry about that. But the 6 radicands can go together. Remember, it's like combining like terms. There is no particular order of the answer. So Miss Delk just went 4 radical 2 because it was happened to be first. And then she combined her 2 radical 6's. So she's got 14 radical 6.
And she ran out of room.
Yeah, not a lot of room in those boxes. And that would be your answer. You could also have equivalent answer would be 14 radical 6 plus 4 radical 2. Okay, there's no really a rule for what order they go in.
You want to do one
let's
before?
One more.
Remember, we always try to simplify first. I can't break down 5 because it's prime, 7's prime, 5 is prime, 5 is prime. So that was already simplified. Identifying radicals that are alike, they must have the same index with the same radicand. So all of those square roots of 5's are like terms, and I'm going to combine them. I have a negative 1 minus 1 more. That would be negative 2 minus another 2. That'd be a negative 4 radical 5. 3 radical 7 is on its own, so I bring it down.
You could have it in opposite order and still be correct.
Commutative property.
Okay, see how easy that is? So we're going to let you try the hard ones because perimeter, you know that you just add all the sides, link them width of a rectangle. It tells you the length and width, and they want an expression to represent the perimeter. So draw it out,
simplest form.
Label it, put it in the simplest form. Okay, so that's today. Look, that video is like 8.5 minutes, so it's pretty easy.